Hello everyone, welcome to my channel. My name is Eric, and um, here I try to solve common interview coding challenges, mostly the ones we can find on LeetCode. So today we'll be looking at one of them, which is the kit. Find the kit largest element in an array. And this is actually the difficulty level is actually medium here. So um, I would so we'll be looking at it together, trying to demystify this challenge. Okay, so looking at the problem, we said given an integer array norms and an integer k, find the kth largest element in the array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Okay, so it's actually not okay. So it's not a distinct element. It's just the largest one, the kth largest element. So this is here the constraint where the level of difficulty actually is centered on, where we have the you must solve it in of n time complexity. So it means that it must be in linear time. So using the inbuilt sorting function will not be allowed. Okay, because that actually takes an n log n time complexity. So let's try to understand what they really want from us. Here we have the inputs, and here we have the output. So here it returns 5. How does it do that? So let's see. Okay, these are unsorted. There's always a rule of thumb in trying to figure out what they actually want us to do. Is always good to just sort the algorithm and see. Then from there we can start trying to solve the problem. So let's assume that I have this norms here is equal to this array. Let's sort this array first and just see if we can have an idea of how to go about this. So if I sort this array, I will have 1, 2, 1, 2, 3, 4, 5, and 6. Yeah. So in this case, I have 6. So find the kits. 5. For me to find 5, k is equal to 2. So array actually starts from 0. So we have 0, 1, 2. This one is 3. Let's see from this end. If we start from this end from the right hand side, so we have 6, 5. So this is actually what we want to return. How do we get here? So in that case, we need to reverse this. So this has to be sorted in a reverse order. So let me remember this. So if we have something like 6, 5, 4, 3, 2, 1. So if we sort it like this, so we can return 5. So we have 0, 1, 2, but we need to return 5. So in that case, what we want to return will become like k minus 1. Yeah. So k minus 1 will return 5 because an array starts from 0, 0, 1, 2. So 1 to return 5 becomes k minus 1. So in that case, we can just come up with a solution, but that will not be our final solution. It's just to have an idea of how I want to go about this. So once we know that we are using a linear time complexity, and it will involve sorting the array. So in that case, we know that we'll be using the quicksort algorithm. So with the quicksort algorithm, we should be able to sort this in linear time. Yes, so but let's just do something here using the inbuilt sort. Just as I said, that's not the final solution. So if I have let's say const sorted sorted norms is equal to norms dot sort, so in brackets, okay, so that'll be bb. So the reverse will become sorry, reverse will become b minus a. Oh, sorry, b minus a. Okay, so here we just return sorted norms k minus 1, because that is the position of the k largest elements. So if we run this, let's see if this will pass. But this is not the answer, because this is going to be in n log n time because of the sorting here. Run n log n time complexity. So yeah, it passed, but this is not what is required of us actually, because this sorting algorithm will run in n log n time complexity, and that is not what they require from us. So, but this will just allow us have an idea of actually what they want from us. So they want us to sort this algorithm, not using the inbuilt sorting function. So we'll be using a quicksort, and then return the kth largest element from the sorted array. So I'm going to sort it in reverse order. Yeah. So if we have that in mind, so we can start. So the first thing I'm going to do here is I'm going to find the position of the kth element that we are going to return. So I'm going to call that position. So position is equal to k minus 1. Okay, so we'll return. So we're going to create a helper function here, which is going to be this is going to be the whole of this algorithm is going to be solved using the concept of quicksort. And yeah, quicksort. So and we also have what we call the quick select, where yes, this is actually similar to quick select, but the difference is just maybe one or two logic. I think that is going to change. So create a helper function here. Maybe we can call it quick select. Yeah, so say return quick select. Okay, so this is what we'll return. So what parameters will be inside the quick select? What parameters here? So we have the norms and other parameters. Let me come here and try to create a helper function. So we have function dot quick select is going to take the array, It's going to take a start index. So we have a start index. It's also going to take the end index, which is actually the last element in the array. And is also going to take a position. That is actually where we have the kit element that we are going to return from this from the sorted array. Okay, so if that's the case, so here we can add those other parameters here. So we have the array. The start index is going to start from 0. The end index is going to be the last element in the array. So we have norms dot length -1. So we are dealing with JavaScript. So that's the last element here. Then we have the position also. Okay, so yeah, so here we can try to write the code for the helper function. So here, first of all, going to use a while loop. So say while true. So while everything inside this while loop is true, okay, we can yeah, the code can keep running. So in here we have to like have a base case that is going to throw an error if the code ever gets to this particular point. So we can say if the start index is greater than the end index, if we ever get to this point, which is not possible, so there's an issue. So it should throw an error. So we want this particular function, sorry, this particular function, yeah, to throw an error. So throw new error. Just write something we want them to see. So this code shouldn't get here. School shouldn't get here. So there's a problem. So so that is for this. Once we take care of this, so the next thing is for us to be able to yeah, we need to like loop through the unsorted array and try to start sorting the array. For us to do that, let me write something here. I'm just going to write the array so you understand. So I can be able to carry everybody along on what I'm trying to do here. So this is here we have let's say we have this norms is equal to this is 3 2 1 5 and 6 and 4. Now, just as I said earlier, our goal here is to be able to sort this array in reverse order and then return the position of the kth largest element. So in this case, if we have k is equal to 2, once we sort this in the reverse order, so our k becomes 6 6 5 4. So k minus 1 will be at position 5 and it will return this. So what I want to do here is at this point, I think let me write something here. Just write to do because yeah, this is where we want to start writing our code now to do. So at this point, we want to start looking through this array. So we can, using the quicksort algorithm, we can choose a pivot index randomly, but I will prefer to use the first. I would prefer my pivot index to be on the first element in the array. So here I can see this is the pivot. Then my start index will be the next available element. So let's say this is my start index. Let's say I call it left index. Then my right index, oh, yes. My right index will be the last element in the array, and that will be, let's say here, right index. So with these values, then I can start to look through the array and start sorting the array. So to do that, here I can see y. Oh no, let me write the values here. So let me define the pivot index and the other parameters. So say pivot comes pivot index is equal to, will be the start index, will be the start index. Okay, then the pivot index, yeah, we're using const because we are not changing it, we're only going to be swapping it. The other ones will be changing, like let's define a left index. So our left index will be the next after the start index, so it will be start index plus 1. Then our right index will be equal to the end index. So we have already defined that here. So it will be the end index here. So here we can create another while loop inside this while loop. So we have while left index is less than or equal to the right index. So while this is true, we want to start sorting the array. So just as I highlighted earlier, earlier on, where we want to sort this array in reverse order, so we have to write the logic here. So I can say that if norms dot left index is, if norms dot left index is less than norms dot the pivot index, if it is less than norms dot pivot index, and norms dot right index is greater than norms dot pivot index. Now, if this condition holds, then we want to swap the values of the left and the right index, because we want the larger values to be in the left hand side of the pivot, and the smaller values to be on the right hand side. That's in that way we can be able to achieve the reverse sorting that we want to achieve. So in that case, we can say swap left index, right index in the array. So so this swap is going to be a function. So let me just quickly define it here. So yeah, so we can define, so function swap, just going to take put any parameters, say ij, whatever, and the array dot swap their elements. So we can first of all define a temporary holder here, and is equal to nums I, and we have nums dot I. We assigned this value to it, and nums dot J. We assign that of the temporary holder to it. Okay, so this is actually the swap function. So here we swap the values if this particular condition ever hold. Then when we do that, so we also have to check if the values if the elements are in their right position. If not, we need to if not, then we need to swap them. So in that case, checking here, we say if nums dot left index, if nums dot left index is greater than or equal to nums dot the pivot index. If it is greater, it shows that it's in the right position, because we want the greater values to be in the left-hand side and the smaller values to be in the right-hand side. So that's reverse sorting. So it's in the right position. So we just move to the next value. So we increment the left. We increment the left index. Okay. Then we also do for the other sub array in the right part of the pivot. So that also follows similar logic. So we have nums dot right index. If it is less than or equal to nums dot pivot index, we decrement the right index. So in that case, it's in the right position, and we just decrement it to the next available value. Let me try to explain. Okay, before I do that, now if all these conditions are met, if all these conditions are met, then we keep incrementing the left-hand side, we keep decrementing the right-hand side until at a particular point where the two, both the left and the right-hand side will overlap. So when they do that, it will no longer satisfy this particular condition where the left-hand side must be less than or equal to the right-hand side. So in that case, it will break out of that loop, and at that point we have to the right index, we have to swap the position of both the right index and the pivot index at that point. So here we would swap the position of the pivot index. I'll explain this, and the right index of the array. Okay. Yeah. So we need to continue here. So let me put to do here and try to explain what we have done here. Now, what I'm saying here is this: so long as this condition holds, we'll keep incrementing and decrementing the left and the right hand side. And if we have this particular condition, we swap the left and the right hand side of the in the array. So what it means is that if we have a condition like here, we have a position, the pivots are 3, have pivot index, have this 3 here. So the left index is 2, so it is less than the pivot index. Let's assume that this is like 6, and let me put 2 here. Okay, now this is like 6. Okay, let me put sorry. Okay, let me put 2 here, and let me put maybe let me put 1 here, so you get what I'm just put 2 or whatever. But it should be, I want it to be less than this pivot index. So if like this particular condition where 6 is greater than oh sorry, no, let's say yes is 2, and here is 6. Yeah, so as you can see, 2 is less than 3, so the pivot is on the position, on this position, so it has a value of 3. So if the left index is less than the pivot index, which is 3 here, and the right index is greater than the pivot index, which is 3 here, so in that case we need to swap both the left index and the right index. So in that case we'll have 6 will be here, and here will now become 2. Okay, to satisfy this particular condition here. Then also we also have to check if the values in the left index and the right index, if they're in the right positions. So for that, the left index has to be greater than the pivot index. So as you can see, this one is greater than the pivot index. So in that case, we need to increment the left index, so we can move this one to this point. And if the right index is less than or equal to the pivot index, we also need to increment the pivot index. So if it was here, we need to move it here. So long as this condition is being satisfied, so long as we are satisfying this condition, so long as we are within this range and all these conditions are being satisfied, we'll keep decrementing the right hand side, and we'll keep incrementing the left hand side, maybe until a particular point where the right hand side would overlap. Let's say the right hand side becomes overlap. Once it overlaps here, let's say we now have the right index here and the left index here, so they have overlapped. So at that point, we'll break out of this particular while loop. And once we break out of this particular while loop, we need to swap the position of the right index, the position of this right index, and the pivot index. So we need to swap their position. So here, let's say we now have something like 3, and here we now have something like 1. Okay, so we'll keep here. So once we do that, so we go back to the initial stage where we have the left index here, then the right index will go back to this, we'll go back here, and we start all over again. So this loop runs again until it is sorted in that particular reverse order. So that is the essence of what we're saying. So once we break out of this loop, so we'll swap both the pivot index and the right index in the array. Okay, so once we do that, the next thing, this is actually where it's a little bit different from the quicksort. And I'm sorry to I didn't ask you that. Please, if you have not if you don't have a good understanding of quicksort, I will encourage you to try to look up. I'm sure there are a lot of videos on quicksort, or a lot of other channels where you can check how to solve how to sort an array using the quicksort algorithm. Please, you need to go understand that before you can actually come solve this particular problem, because everything here is centered on the quicksort algorithm. It's actually the concepts that we are using here. So please try to go understand how to solve quicksort before coming here. I'm so sorry I didn't add that before we started, please. So sorry about that. So let's continue. So here we have been using the concept of quicksort, but here this is actually where we are going to deviate a little bit, because here at this particular point, once we get our pivot index, swapping the position for we swap where the right index value and the pivot index value is. So once we swap that, so at that particular point, we need to be able to check if the position of the right index is actually where the kth value is. If it is, we just return that particular value. So we're going to write the logic here. So we'll say that if the right index is equal to the position, okay, now if this is true, then we just return the value. So it means that we have found our kth largest value. So we return norms dot right index, else if the right index is less than the position, so if we are on the left side of the pivot, so we want to say that the start index will be equal to the right index plus 1. Okay. Yeah, right index plus 1. Else, it will be on the other side of the pivot on the right hand side. So else the end index is equal to the right index minus 1. Yeah. So this is it. So at this point, we are trying to like find check if the position of the right index is actually where we can find the kth value. If it is, then we just return it. If not, then we'll check the left side of the pivot and the right side of the pivot also. So that is how the algorithm runs. So let's try to remove all this and just run and see if it passes. If it passes, yeah. Okay, so yeah, see, let's run. Okay, so it passes. So we are going to submit and see if it's going to pass all the tests. Just as I said, this is going to run in O of this will run in O of n time. I can add it here. I can just add it's going to run in O of n time complexity and O of one space. So it's at constant space because we didn't create any extra space here. We only just we are only trying to sort what is in the existing array and returning it. Then just return the kth value inside. So we are not using extra space here. O of n time, as you can see, we are just have one while loop. So I think normally it should be O of 2n, but at the end of the day, we just reduce, it will be reduced to an O of n time. So, and that actually meets this particular constraint that is here. So if we try to submit this and see, Okay, so as you can see, it passes. Sorry, it passes, and it took about 104 milliseconds. Okay, well, I really don't believe in all these ones. Yeah, so can go back and yeah, so that is how to solve the kth largest element in an array in an O of n time complexity. Thank you so much for being here, and if you like um, how I solve this coding challenge, you can actually just leave a like so that other people can see can also see it and also watch other programmers can see and also learn one or two things from it. Thank you so much and have a wonderful time.